further ado, let's jump right in. So the first topic we're going to cover is called kinematics. And kinematics is essentially the study of how particles move when they're given a speed and acceleration. So we're going to study the motion of how things work. We're not going to understand why things will behave the way they do, but we'll understand if they do behave this way, what happens, right? So this is kinematics. This is the foundation of all of physics. So just a few course expectations. We have 16 weeks. We're going to end basically before the physics exam. So you guys have maybe a week to review the material in advance of the AP exam. So we have 1 hour of lecture a week. This is, unfortunately, I was forced to move this forward a little bit because I have an interview right after this. So yeah, 1 hour lecture a week. For all the future lectures, it's going to be from 3:30 to 4:30 Eastern time. If you have any questions, just ask them in the chat. Or just unmute your mic so we can just ask it verbally, so we'll give you a better explanation. If you haven't yet joined the Discord, so you can ask questions to your classmates about the homework or anything. And it's highly recommended, hopefully most of you guys did this, to read the pre-lecture readings before lectures so you have an idea of what we're going to be covering. Of course, during lecture, we're not going to expect you to know this, but to know the material beforehand, but it will obviously help if you do. So yeah, these are kind of the expectations. And what's going to happen is I'm going to introduce a topic. You guys are going to ask questions about it, and then we're going to go over some practice problems. And while you're working through the practice problems, you can direct message me. Make sure to private message me your answer, and I can give you feedback on your answer. Or you can just keep your answer to yourself, and I'll go over the answer, and you can just double check it, your own answer with mine. So that's kind of how the vibe will go for lecture. And homework will be released in classroom right after this. Okay. In class today, we're going to cover kind of a lot of foundational definitions. So we're going to start off with speed and velocity. I'm going to cover reference frames, acceleration, some graphs, and then the bulk of kind of what our time will be focused on is the kinematic equations of motion. Okay. So the first idea, and if you're wondering about, okay, should I take notes or not? I do recommend you guys to take notes, but all the slides will be posted later. So all the key information will be on the slides. But it is good to take notes while you're learning. So the first idea we have is speed and velocity. So these are kind of two words you probably heard of before, but in physics, we have a specific way of defining them to make them different from one another, and they mean different things. And it's really important to kind of figure out the difference in these definitions. So speed is a scalar. So if you've learned algebra, a scalar is just a value. It has no direction involved with it. So speed is always a positive number. So it defines basically how fast I'm moving in space. It's a number with no direction. Velocity is what we call a vector. It has a direction and a magnitude. So my velocity will sometimes be denoted with an arrow, which basically says, okay, how long the arrow is how fast I'm moving, and the direction that the arrow is pointing in defines the direction I'm moving in. So these two definitions, a speed is the total distance I travel over unit time. So here, S is what I denote my speed, and it's equal to distance over change in time. So if I travel a distance d, and this distance, for example, if I go in like this curvy path, this distance is the total length of the path. So I'm going to find this total length. And if delta t, so delta is kind of a symbol we use to note, which is change. So the change in time, so the amount of time it took for me to go on this path, d over that time is going to be my speed. And I don't care about direction here, so I'm just simply measuring the length of the path, right? We don't care about the direction. The velocity depends on the displacement traveled over unit time. I compare only my starting point and my finishing point. I don't care the path I took in getting there. So what does this mean? If I went on this path like this in time t, my velocity is directed in this direction, and it only depends on the change in my position. Okay? So my velocity is actually delta x over delta t, which is the distance between my starting point and my ending point. I don't care the path I took to get there. It's just that shortest distance between my starting and ending, and this is my velocity. So speed and velocity are very different in this sense. And velocity, since it's a vector and has direction and magnitude, if we say velocity is positive in this direction, In the other direction, we have to call it negative. Okay? So if you imagine an XY plane, basically, this is the y-axis, this is the x-axis. If I'm going in the x direction, then my x is increasing, right? If my x is increasing, delta x will be positive, so velocity is positive. If I go in the other direction, my x coordinate is going to decrease, it's become more negative, and then my delta x would be negative, so my velocity would be the opposite sign. So it really doesn't matter which you say is positive or negative, as long as you say, okay, if this direction is positive, if I go in that direction, my velocity is negative. Okay, so velocity carries magnitude and direction, speed only carries magnitude. I'm going to stop for questions here. You can either raise your hand or just type in the chat any questions anyone has. So Brandon says, what is the definition of magnitude? Magnitude is just a value, so how big a number is. So it's just a scalar is pure magnitude. It's only a number. So it's like 3 meters per second. 3 meters per second is just magnitude. It's how big my speed is. Positive 3 meters per second, or specifying a direction, would be a vector. That makes sense. So 3 is like the magnitude. It's the number that defines how fast I'm going. So it could be 3, it could be 5, it could be 10, whatever.